Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for 6.1.1. In this first problem, our task is to create a set of directions that you could use. Now remember, there are a lot of different combinations that we could do here to get from point A to point B, but these are just two of the possibilities of what you could do to get from this original into this location here. Now, typically, my first step, I'm going to go ahead and write this out, is I like to refer to this as a reorientation. The reorientation is where you either rotate or reflect this shape so that all of the corresponding parts are in the same location. So here's the right angle, there's the right angle. Here's one point that corresponds to this point, a second point to this point, a third point to this point, and then the longest side of the triangle is in the same location as the longest side here. So we always want to start with a reorientation. So to do that, I chose to reflect this particular triangle over the x-axis where y is equal to 0. So with that being our line of reflection, let me go ahead and thin that out a little bit. With this being our line of reflection, we take every point on the original and find its reflection on the other side. So however many units it takes you to get there, you're going to go the same number of units beyond. And once you've got those 3 points in place, then you just connect the dots with straight lines. So there's our reflection. The second step, all we have to do is slide it to the right. So every one of these units, every one of these points moves the same number of units to the right. This one takes 1, 2, 3, 4, 5, 6, 7 units to get into place. This one should take 7, 1, 2, 3, 4, 5, 6, 7, and this one should take 7, 1, 2, 3, 4, 5, 6, 7. So in all of those situations, we moved 7 units to the right, where you use the coordinate notation of x plus 7, but it's y plus 0 because we did not go up or down. So that completes it in 2 moves. We started with a reflection, then did a slide. Now I've had some students that have done this with 2 reflections, where the first reflection, they went and crossed over where x is equal to 0, where this becomes here, this becomes here. Oh no, that would not work. No, that would not work because then you would have to do some kind of a rotation. Okay, I take it back. I like this method right here, doing it that way. All right, so moving on to something that is not new, something that's review is, well, let me just read it. Review what you know about the graphs as you complete parts A through D below. Okay, so find the equation of the line that passes, I'm doing a terrible job of reading. Okay, I have to do much better now or else we're gonna waste too much time. Find the equation of the line graphed to the right, and that's the black line. Okay, that was the original one. And remember, to do this, you want to find some different points. In fact, let me see if I lock this in. I guess I have locked it in. Okay, so you want to find some different points on that line and then figure out what is the growth rate and what is the y-intercept. Well, this is the y-intercept right there. So we know that's going to be something times x plus 1. And then the growth rate, remember, we're looking for the change in y over the change in x. And so to get from, say, this point to here or this point to here, it looks like it always goes down 2 and then 1 to the right. So that means that our slope, m, is going to be equal to -2. So we'll put that number right here, and that's our rule. So for every point on this line, every one of those points is going to be defined by y equals -2x plus 1. So this point right here is -1, 3. So if I plug in -1 here, that's -2 times -1 is +2, and 2 plus 1 is 3. That is correct. Our y-intercept, obviously, when that is equal to 0, 0 plus 1 is equal to 1. And then we could go down to this point down here where x is equal to 2 and y should be equal to negative 3. So negative 2 times 2 is negative 4, and negative 4 plus 1 is negative 3. So yes, our rule is correct at y equals negative 2x plus 1. So what are the x and the y-intercepts? Well, the y-intercept, we already got it here. It's at 0, 1. And then the x-intercept appears to be at 0.50. So now, on your own graph paper, graph the line. And on the same set of axes, graph a line that is parallel and passes through 0, 0. Well, if it's parallel, we know that they have the exact same slope ratio. And if it passes through 0, 0, that means that the rule, actually let me write that in blue, the rule would be negative 2x plus 0, but we're not going to bother saying plus 0 because that doesn't help us with anything. So we just end up with this as a proportional type of line, right? Straight line passes through 0, 0. This is the form that that takes. And the growth rate, or the unit rate in this case, would be negative 2. All right, which equation below has no solution? Well, after sending in the dive bombers here, you get 4x plus 4 is equal to 2x plus 4. And I'll tell you right now, when you've got the same number of x's on each side, that's when you know it's either going to be a no solution or an infinite solution. If you've got more x's on one side than the other, you know you will have one solution. It's just a matter of what is that one solution. So when you take away 2 x's from each side, and then you take away 4 from each side, you're left with this situation where you get 2 x's are equal to 0, right? Because 4 minus 4 is 0, and 2x minus 2x is 0. So at this point, what number do you multiply times 2 to give you 0 for an answer? Well, that would be 0, because 2 times 0 is 0. So x has to be equal to 0 here. Let's prove it. If x was equal to 0, this would become 4 times 1, and that would be equal to 4. If x were equal to 0 here, this would become 0 plus 4, which is also equal to 4. So yes, 4 is equal to 4. That's a true statement, which means this is the correct solution. In this case, what we end up with is an equation after we combine like terms, right? 9 and 2 make 11. And then if you rewrite this as negative 5x plus 4 instead of 4 minus 5x, then you can see that you got negative 5x's plus one number can't be equal to negative 5x plus a different number. That's impossible. And so, you know, if you show these steps where you cancel out the x's, you're left with 11 is equal to 4, but we know it's not equal to 4. So that means that there is no solution for x that would ever work in this situation. Rena says that if x is equal to negative 5, the equation below is true. But her friend Dean says, no, it's got to be x is equal to 3. So who's correct? Okay, so to justify your conclusion is where you actually do the checks, right? So if you plug in negative 5 here and negative 5 here, what do you get? Negative 5 plus 1 is negative 1. I'm sorry. Negative 5 plus 4 is negative 1, and 9 times negative 1 is negative 9. Here you end up with 1 plus negative 10, because 2 times negative 5 is negative 10, and 1 plus negative 10 is negative 9. So that proves that the solution is x is equal to negative 5. Now, there is the possibility that there could be infinite number of solutions. So we should check to see if Dean is also correct, because maybe that's the case. So you plug in the 3 here, you get 9 times 7 is 63. You plug in the 3 here, you get 1 plus 6 is 7. No, that is not right. Rena is correct. Dean is wrong. All right, problem number 6. Find the rule for the pattern that is represented at the right. Okay, so to get to the rule, you probably, I think, would be the best idea to go through and create a table. So you can find out what the y-intercept is and then look for the counting sequence to figure out what the growth rate is. And that's what we did here. If you get 3 and 7 and then 1 and 11, then that means that we were counting by 2s, right? If you go in this direction, you're adding 2. If you go in this direction, you're subtracting 2. So let's go in this direction. And so 7 makes 9, 9 makes 11, 11 makes 13. So we think the rule is y equals negative 2x plus 13. So how can we prove it? Let's plug in these values for x and y into the rule to prove that both of them work. If x is equal to 1, this becomes negative 2 plus 13, which is equal to 11. So yes, that rule works for figure 1. And let's check this one now. If x was equal to 3, that becomes negative 6 plus 7, which is, no, not plus 7. What am I doing? I might, not having a good time here. Not doing a good job at all. Okay, so this is supposed to be 13. So plus 13, which would equal 7, and yes, that's how it's supposed to work. Okay, so setting up a table. Now there is a formula that we could use, and would you like to see what that formula looks like? Y minus y1 is equal to m times x minus x1. But you'd still have to figure out the slope ratio, and then you'd still take one of those points, and I'm just going to leave this for Del Oro. Your high school math teachers will teach you all about the point slope form of this rule. Remember, this is slope intercept form. This is point slope form, because this represents the slope, and these are the coordinates from one of your points on that line. And so if we're going to plug in this guy here, that's the 7, that's y1, and we plug this guy in here, that would be the 3, and the slope we figured out was negative 2. Then when I use distributive property, that becomes negative 2x plus 6. And then when I add 7 to each side, that's going to become the 13, and that'll give you your rule. But once again, I'm going quickly because I don't expect you to learn this and remember it. That's for high school. All right, and now we have a system of equations type of a problem. We've got two different hippos here. We've got Homer, hungry hippo, and he is munching lily pads in his pond. When he got to the pond, there were 30 lily pads, but he's eating 5 lily pads per hour. Then you've got Henrietta the hungrier. She found a better pond that had 38 lily pads, and she is eating 7 per hour. So can you see how we came up with these two rules? Homer the hungry hippo has 30 to begin with, and he's eating at a rate of 5 lily pads per hour. So X represents the number of hours, and Y represents how many lily pads are remaining. So that goes with Homer. Henrietta, she's got 38 to begin with, and she's eating more per hour. That's her rule. So the question is, if they start eating at the exact same time, when will both of their pools or ponds, whatever, have the same number of lily pads? And then how many will there be? So let's go ahead and solve the system of equations where if y is equal to this and y is equal to that, then this has to equal that. So let's go ahead and say negative 5x plus 30 has to be equal to negative 7x's plus 38. So I'm going to choose to add 7x's to each side so that I'll get a positive 2x's on the left-hand side. And at the same time, I will take away 30 from each side. And so that's going to equal 8. So 2 times x is equal to 8 means that 1x has to be equal to 4. And in this case, since it's their rate, x represents the number of hours that they've been eating, then this translates to 4 hours. In 4 hours' time, they will have the same amount. Now, we can prove that by setting up a table if we want to. Let's do. Right. Let's just look at our consumption level for each one of these people, or hippos. Stop it. Yes. I'm so ready to be done with this. Just want to move on. It's getting late at night. So this is X. This is Y. He starts in 1 hour. He has 30. No. At the beginning, he has 30. In 1 hour, he eats 5, so he's got 25. And in 2 hours, he's got 50. I'm so sorry. 20. In 3, he's got 15. In 4, he's got 10. Now let's look and see how Henrietta does. For her, she starts off with 38. In 1 hour, she's eaten 7. In 2 hours, she's eaten 14. In 3 hours, she's eaten 21, which means this is going to be at 17. And in 4 hours, she has eaten 28, which means she's at 10. So there you are. We just proved after 4 hours, we solved it algebraically, and then we used a table. Okay? So if we know it's in 4 hours, let me get rid of all that. Then we use the table to determine that they would each have 10 lily pads left. But I'm going to now use this and solve it algebraically. So 5 times 4 is negative 20. Negative 5 times 4 is negative 20. Plus 30 is equal to negative 10. So that's what y would equal, the number of lily pads in the pond. And here, negative 7 times 4 is negative 28. And negative 28 plus 38 means y is equal to 10. So that confirms our answers. In 4 hours, there will be only 10 lily pads left for our 2 hungry hippos. And I am done. 15 minutes was about 12 minutes too long. I'm getting tired and I've got one more to do, but I'm going to do it and I'm not going to make any mistakes on the next one. So let's move on to the next activity. Take care. Bye.
Hey, feeling good.